Two friends share a paper route. Sheena can deliver the papers in 40 minutes, and Jeff can cover the same route in 50 minutes. The question is, how long to the nearest minute does the paper route take if they work together? Okay, so it's helpful to have a table to organize your information. It's not necessary, but it's helpful. If we take a look at the question, how long to the nearest minute does the paper route take if they work together? Then we know that our let statement is going to reflect that question. So let, and we use t for time, so we're going to let t be the time it takes for them to do the route together. Okay, so in filling the chart, the first column will have the names of our characters, so Sheena and Jeff, and we also want to include together. Okay, if you take a look at the problem, our time is in minutes, so when we fill in our second column here, we have to recall that our time is in minutes, so Sheena can do this paper route in 40 minutes, and Jeff can do it in 50, and we don't know what their time is together. Okay, so we want to know what the fraction of work is done in 1 minute. So if Sheena takes 40 minutes to deliver the papers, then the fraction of her work that she will get done in 1 minute is going to be 1 over 40. And if Jeff can do it in 50 minutes, then the fraction of the work that he can get done in 1 minute is 1 over 50. And for t, following this pattern, you know the next one has to be 1 over t. Okay, so the next thing we want to ask ourselves is, what fraction of the work is done in t minutes? Okay, that's the time that they do it together. All right, well, if 1 minute is 1 over 40, then to find out what the fraction of time it is for t minutes, we have to multiply. So we're going to go 1 over 40 times t, which will give us t over 40. And then for Jeff, we're going to go 1 over 50 times t, which is t over 50. And for the time together, 1 over t times t, which is t over t, which just gives you 1. Okay, and just recall from class, this value will always be 1. Okay, so what is our equation for this? Well, we know that if we take the part of the time that Sheena can do the work in t minutes and add that to the part of the time that Jeff can do work in t minutes, that should give us a whole complete job. Okay, in this case, doing the paper route. So we're going to add those. We're going to go t over 40 plus t over 50 is equal to 1. So as you can see, we have a rational equation. Our LCD is 200. Okay, and so we're going to multiply every part of our equation by 200. So we're going to go 200 times t over 40 plus 200 times t over 50 is equal to 200 times 1. Okay, so let's do some reducing. 40 goes into 200 5 times, 50 goes into 200 4 times, and there's no reducing on the right. Okay, so we get 5t plus 4t is equal to 200, and that gives us 9t equals 200, and then t is equal to 200 over 9, which gives us about, let me put this, about 22 minutes. Okay, now you can check your work, but don't check with the fraction, check with the fraction. Okay, so we go back to our original equation, plug in 200 over 9 for t, Okay, remember that when you divide fractions, you multiply by the reciprocal. Okay, and 40 goes into 200 5 times, so that gives you 5 over 9 plus 50 into 200 is 4 times, so 4 over 9. And 5 over 9 plus 4 over 9 is 9 over 9, so 1 equals 1, and we can show that left side equals right side. Okay, and so it takes them about 22 minutes to complete the paper route together. Okay, so we're done this one. Let's move on to our second word problem.